the supervolcano that is a continent killer, and it blows every 600 to 800,000 years. And everyone dies just when we thought Yellowstone's geological drama couldn't get any more intense. Officials dropped a bombshell. The park has experienced hundreds of earthquakes in the past months, and many geologists are terrified of the impending implications. The latest warning from the United States Geological Survey is absolutely terrifying. Specifically, in the last month, seismologists have documented more than 1,000 minor earthquakes shaking the ground beneath Yellowstone. Given the park's volatile history and the unpredictability of its big supervolcano, this is a major cause for alarm. This announcement has put the world of science on high alert. Are we on the brink of disaster? Could this seismic frenzy signal the awakening of the supervolcano lurking beneath Yellowstone's surface? Join us as we delve into the heart of this seismic storm and uncover the truth. Yellowstone officials give serious warning after hundreds of earthquakes hit the national park. Yellowstone needs no introduction regarding its highly diverse and dynamic geothermal activities and hydrothermal features, which make it the most fascinating park in the United States. It pulsates with life, continuously reshaping itself through these processes. This perspective reflects the boundless nature of life around us, but not to get carried away. Our primary focus lies in the scientific and geographical past events that reformed Yellowstone into what we have today. Yellowstone National Park encompasses a vast expanse of land measuring 2.2 million acres, covering parts of Wyoming, Montana, and Idaho. Various wild animals are found within its expanse, including the pronghorn, coyotes, wolves, and American bison. Despite its reputation as a potential ticking time bomb due to underground turmoil, Yellowstone's beauty draws photographers worldwide seeking the perfect shot amidst the subsurface chaos. Long before it was designated as a national park, Yellowstone was the residence of many Native American tribes, including the Crow, Shoshone, and Blackfeet. These tribes not only settled down in the land, but also held it sacred. However, the majority of their history is speculation accompanied by myths, stories, and legends because the region's turbulent past destroyed many facts. Regardless, the fact that they inhabited the scene and took care of its surroundings is an opportunity to discover the beautiful heritage miracles Yellowstone is famous for. Nevertheless, there are those who are under the impression that the souls of the tribes are still present in the wilderness of Yellowstone. In the 18th century, the area did not exist in the minds of the Euro-American settlers unless you were either a Native American or an explorer. Strangely, it was recorded that Europeans sailed into these regions in the late 18th century. Records indicate that the Lewis and Clark expedition from 1804 to 1806 played a crucial role in mapping these territories. The frontier scientist Lewis led his group north to explore the Marias River, but Clark, the soldier mapmaker and self-taught physician, led his group southeast to explore the Yellowstone area. Although the expedition did not directly explore Yellowstone, it laid the groundwork for future exploration. Decades later, in 1869, a group of non-Native Americans, led by David E. Folsom, conducted the first documented trip into what is known as Yellowstone today. It was the first to record its natural beauty, although it was modest in scope. This expedition set the stage for the beginning of the Pacific to European exploration. After that, more expeditions, including the Washburn-Langford-Doane expedition of 1870, were launched in succession. The most significant undertaking in the region is the exploratory project of the Hayden Geological Survey in 1871, organized by geologist Ferdinand Hayden. Sponsored by the federal government, the expedition not only explored the region, but also had the task of carefully and correctly recording the details of Yellowstone's beauty. During the mission, Hayden and his team, including artists, scientists, and photographers, spent a few months examining and mapping the region. This was the natural starting point for future scientific endeavors and exploration. Their records established the first artistic depiction of Yellowstone's landscape. At the end of the 18th century, the conclusions from their explorations became the basis for its official designation as the first national park in the world on March 1st, 1872. Despite all that has been said about Yellowstone Park, one might question, isn't Yellowstone just like any other park in the United States? Well, it's not. The park, besides its excellent scenery, extravagant wildlife, and imposing human essence, is famous, among other things, for its great thermal features. These features include hot springs, mud pots, geysers, and many more. Among these wonders is one of the world's most renowned geysers, Old Faithful. As a symbol of Yellowstone's beauty, Old Faithful erupts with a faithful rhythm of 60 to 90 minutes, sometimes ejecting more than 8,000 gallons of water upward. It has been reported that historically, the Old Faithful geyser would spurt 185 ft into the sky, an absolutely stunning spectacle of nature's mighty power. These unprecedented scenes leave no room for doubt about the park's unrivaled originality. No other word can better describe the majesty of these geological wonders than Yellowstone, as people revere it upon seeing it in person. But wait, there's more. Did you know that beneath the geysers, pools, and waterfalls, Yellowstone also conceals one of the largest volcanic systems on the planet? The Yellowstone Caldera is among the largest volcanic systems worldwide, hosting a tremendous magma reservoir beneath its surface. This system is responsible for creating extensive thermal features scattered throughout the park. Besides, the park's thin Earth's crust makes it the center of the universe of geologists worldwide who dedicate their lives to understanding the complicated relations between different geological bodies. Dr. Robert Smith and other scientists, such as Dr. Lisa Morgan and Dr. Mike Poland, engage in extensive research on earthquakes and volcanic processes in Yellowstone. They regard the park as a field lab for geographical analysis and a natural jewel of international importance. However, their idea of Yellowstone as a laboratory might seem exaggerated to some, particularly considering the constant tremors and risks present. Safety issues such as rocks, landslides, faults, or cracks during earthquakes are among the major setbacks limiting most people from exploring the area. This only reminds us to acknowledge and respect the scientists and park personnel for their bravery and commitment to containing earthquakes as they happen often in the region. When we hear the name Yellowstone, we cannot help but associate it with catastrophic events, since it tops the scale due to its high seismic activity. And here's a fun fact. Did you know that over 1,000 seismic activities happen in Yellowstone each year? This daunting number indicates how much seismic activity there must be in this region. With such a large number of earthquakes reported in the Yellowstone area, one may legitimately urge the complete sealing off of the environment to save human lives. However, while this may seem like the best option, it hasn't been deemed necessary yet. This is because earthquakes are natural phenomena and part of the park. It is necessary to acknowledge that earthquakes differ significantly in their magnitude and consequences, which makes it difficult to predict the outcome of this natural disaster in a specific location. Some earthquakes could generate profound changes in natural phenomena and damage construction. Meanwhile, some others only create tiny underground tremors, which are not noticeable and do not crack rocks or land. Severe earthquakes are generally recognized by large magnitudes, while small magnitudes sweep off less catastrophic ones. Taking into account that all recorded seismicity at Yellowstone is of smaller magnitude, there's currently no immediate cause for concern. Nevertheless, we need to state that there have also been considerable earthquakes in the past. Although recent earthquakes in Yellowstone may have gone unnoticed by some, a more recent event left a lasting impression on the population and scared the residents. One such case was the Hebgen Lake event on August 17, 1959. A massive earthquake of magnitude 7.3, known as the Hebgen Lake earthquake, shook the region. This earthquake caused devastation to the park and led to landslides everywhere, claiming many lives. To this day, much of the fallen area still shows signs of that destruction. Besides the Hebgen Lake earthquake, there's the Bora Peak earthquake, that struck Idaho in 1983. Despite the fact that it was less seismic than the Hebgen Lake catastrophe, with a magnitude record of 6.9, this event still left behind significant damage that spread across Idaho and neighboring states like Wyoming and Montana. Ranked as one of the largest earthquakes to hit the U.S. after Hebgen, it further illustrates the diverse range of seismic activity experienced in the Yellowstone region. This reflects the magic of Yellowstone National Park and highlights its ability to withstand no matter what kind of geological hazard lies in wait. While there have been a lot of really tiny earthquakes after the Hebgen Lake and Bora Peak earthquakes that didn't receive much attention, all seems good. These earthquakes are a good indicator of the constantly changing nature of Yellowstone Park and the ongoing geological processes working on shaping the landscape. It seems the geological mechanisms underlying the hundreds of earthquakes occurring at Yellowstone National Park are more closely related than previously imagined. This leads us to the crux of our discussion. What are these mechanisms, and how did earthquakes become a prominent topic concerning Yellowstone? When it comes to geologic science, we have come to understand that while earthquakes are scary, they occur in various regions. Reading the history of the most dreadful earthquakes globally, including the Lisbon earthquake, the Great Chilean earthquake, and the San Francisco earthquake, among others, we remember the danger of these natural disasters. These events were the product of specific geological processes. Similarly, the earthquakes at Yellowstone result from geological forces, with the main difference in frequency and magnitude compared to historical earthquakes. However, there's further room for categorization. For instance, let's consider the Lisbon earthquake of November 1st, 1755, a dark day for the Portuguese capital. With a magnitude of 9.0, this earthquake unleashed wildfires, tsunamis, and multiple faults and fissures throughout the city, bringing unprecedented havoc and chaos. The Doomsday earthquake is believed to have occurred due to the movement of tectonic plates along the Eurasian and African plate boundaries, specifically the Azores-Gibraltar transform fault. This caused the release of an immense amount of energy, resulting in catastrophic devastation for Lisbon. While the cause of this earthquake lies solely in tectonic movement, the situation at Yellowstone presents a more complex scenario. In Yellowstone, the connection between earthquakes and their causes might have similarities and differences with the earthquakes in Lisbon. Both locations are subject to seismic activity, but the underlying causes differ. Yellowstone's seismic activity is partly caused by a tectonic system running east to west and through an underlying volcanic system. Let's not forget the looming presence of the supervolcano, which lies at the very core of the national park. It is the largest and one of the most formidable volcanoes on Earth. The supervolcano has been recorded to have erupted 3 times in the last 2 million years, and its impact on geological history is evident. A supervolcano differs from a typical volcano in that it brings forth unimaginable catastrophes to the Earth with its great magnitude of eruptions in size. No doubt, the mechanism in Yellowstone may differ from that in Lisbon. However, the underlying physical processes and potential magnitude of disastrous events warn us of the need for continued monitoring and research. The last supervolcano eruption, which happened approximately 640,000 years ago, affected not only the crust, but also the stratosphere and climate. The eruption contributed to the deposition of ash, mud, and other volcanic matter that changed the landscape of North America for an extended period. Drawing to this, the whole planet is at risk of being affected by the catastrophic consequences of the volcanic activities that may come from the supervolcano in Yellowstone National Park. The volcanic system and magma chamber situated under the supervolcano can have a massive impact on the world. Although the supervolcano is mainly inactive today, the volcanic complex and gurgling magma chamber underneath are still highly active. This activity is demonstrated through a series of successive earthquakes that occur in the area. The magma chamber reaches depths of several miles underground, thereby increasing the pressure on the planet's crust which in turn forces it to expand and contract due to interactions between earthquake faults. Several small earthquakes or earthquake swarms occur. Considering that the magma chamber is constantly active, it comes as no surprise that a considerable number of earthquakes hit Yellowstone. Observing these geological processes is crucial for proper hazard assessment and reduction of the seismic activity of Yellowstone. Suppose the volcanic system is not the origin of the seismic activity in Yellowstone. In that case, it must be the forces of the tectonic plate at play. The Earth's crust continuously bears the brunt of the immense pressure arising from the collision and reforming of tectonic plates. Gradually, this tension piles up and is then transformed into energy. This energy finally translates into earthquakes. However, the kinetic energy of the earthquake is not as intense as that of a shocking disaster like the Lisbon earthquake. One hypothesis holds that the park geysers may have an impact on the equilibrium of seismic activity. These geothermal characteristics, primarily sustained by the volcanic system, play a role in maintaining stability below the surface. Consider the analogy of a whistling kettle. The kettle represents the park, while water symbolizes magma below the Earth's surface. Just like water is pushed to boil by continuously increasing the pressure, steam is unleashed on occasion to help release geological pressures. From a scientific perspective, some geysers push water upwards to different levels because of pressure, which is the same way magma gets to the surface. This symbiosis of geothermal energy and tectonic forces manifests Yellowstone's wonderful geological features. Although the volcanic system and tectonic activity operate separately, they are interdependent, making the system sensitive to seismic events. As a result, the region's geological processes remain dynamic and continuous. This means that Yellowstone National Park will likely continue to experience a series of small earthquakes. Although this can be considered an issue, it should be understood that these quakes are essential, as they are one of the park's hydrothermal activity maintenance strategies. Like the previous analogy, earthquakes regulate the pressure underground, thus paving the way for the development of new hydrothermal zones. Earthquakes occur by creating gaps that allow water to interact with hot rocks conducive to forming geysers, hot springs, and other hydrothermal features. Hence, earthquake swarms happening here do not mean the end of the park. Nonetheless, the nature of time growth is an issue. In contrast, it portrays this powerful event as a dynamic interplay of seismic activity and the volcanic system that over time has formed the geological landscape of Yellowstone. As far as the volcanic eruption is concerned, the sequence of earthquakes in volcanic systems can reveal a lot of precious information. While different seismic events may signal that an eruption could be imminent, the real hint will come from ongoing monitoring efforts. So, whose mandate is to supervise Yellowstone's seismic and volcanic events? Some organizations are mandated to guarantee safety within the park. These entities comprise governmental bodies, research institutions, and park management groups that are collaboratively tasked with assessing risks caused by Yellowstone's volcanic system. Although many groups are engaged in monitoring seismic events in Yellowstone National Park, the Yellowstone Observatory and the U.S. Geological Survey, USGS, are the primary agencies responsible for warning the affected population about possible catastrophes. These institutions do a fantastic job of recording all seismic activities in the area. Furthermore, the University of Utah seismograph stations equally contribute by compiling all seismic activity records in the last 10 years, from 2010 to 2019. Seismographs from the University of Utah organizations have recorded 17,245 earthquakes in Yellowstone regions. That translates into 4.7 earthquakes every day. Interestingly, there's been a surge of 330 earthquakes compared to the previous decade. These monitoring stations will be able to track seismic activity using seismometers, GPS satellite images, aerospace surveys, and sophisticated computer models. With advanced data analysis techniques, these state-of-the-art surveillance techniques help us obtain more details about seismic phenomena so we can detect patterns, predict seismic events in the area, and calculate a threat level. They continuously collect and analyze data because they regard it as a central factor in ensuring public safety and preparedness for predicting a geological disaster. While high technology and complex equipment play a significant role here, an inseparable element of this field is the selfless people who devote their lives to geological monitoring. They are the guardian angels who bring us hope in stormy times of potential geohazards. Organizations displayed a new level of commitment when they took on their responsibilities after the Maple Creek coverage of June 12, 2017. It was a beautiful day in Maple Creek. The sun shined brightly, the air was fresh, and everything seemed normal until the ground started moving. People were suddenly alarmed. What began as a slight shiver of the trees rapidly grew into a scenario where trees shook heavily, making tones similar to those of a pale girl running through the woods in a horror movie. The cause of these strange occurrences was investigated. The results showed that the geological activity below the town caused heightened seismic activity, prompting immediate safety measures. Within Yellowstone, the focus has been on Yellowstone Lake to monitor seismic activities. The analysis of a broad survey of earthquake data from 1983 to 2008 further deepened the researchers' interest. Out of the 250 earthquakes recorded, the strongest magnitude was registered in the lake with a remarkable magnitude of 3.9 on the Richter scale. This research emphasizes the value of constant observation and awareness in preparing measures in case such geological events occur. The main purpose is to use the lake region as a reference point in recording seismic activities all over Yellowstone. Regardless of scientists' inability to decipher why the lake exhibits distinct seismic behavior, the main concern is the possibility of the lake erupting. As a result of this realization, all our energies are devoted to establishing necessary safety features to minimize casualties.